Building a Lego bridge across the Atlantic Ocean is a feat that combines the whimsy of childhood with the terrifying reality of materials science and structural engineering. To understand if this is possible, we have to look at the numbers, and they are, quite frankly, astronomical. 1. The blueprint, distance and scale. The shortest distance across the Atlantic from Brazil to Liberia is approximately 2,800 kilometers, 1,740 miles. However, if we want to connect New York to London, we are looking at roughly 5,600 kilometers, 3,500 miles. Let's assume a modest bridge that is 10 meters wide, enough for 2 lanes of cars, though driving on Lego would be a nightmare for your tires. A standard 2x4 Lego brick is 3.2 centimeters long and 1.6 centimeters wide. To cover the length of 5,600 kilometers, you would need 175 million bricks just for a single line. To make it 10 meters wide, that single layer becomes 109 billion bricks. The depth problem. The average depth of the Atlantic is 3,600 meters. To build a bridge that isn't floating but stands on the ocean floor, you would need a wall of Legos roughly 375 bricks high for every single meter of depth. Total piece count. For a solid causeway, we are talking about roughly 10 to the power of 15 to 10 to the power of 16 bricks. That is tens of quadrillions of pieces. For context, the Lego Group produces about 60 billion bricks a year. It would take humanity's current production capacity over 160,000 years just to supply the parts. 2. The pressure. Will the bottom layer snap? This is where physics gets mean. A standard Lego brick is surprisingly strong. It can withstand about 4,240 newtons of force before it deforms, roughly 432 kilograms. The stack problem. If you stack Legos 3.6 kilometers high, the weight of the column itself becomes the enemy. A single 2x4 brick weighs about 2.5 grams. A stack 3,600 meters high would consist of about 375,000 bricks. The weight pressing down on the bottom brick would be roughly 937 kilograms. Verdict. The bottom brick would shatter. It exceeds the maximum load capacity by more than double. Your bridge would effectively melt at the bottom, turning into a plastic sludge on the ocean floor as the weight of the Atlantic and the plastic above it crushes the structure into dust. 3. The ocean. Currents and salt even. If the bricks didn't crush themselves, the Atlantic is not a bathtub. Thermal expansion. Plastic expands and contracts with temperature. The difference between the frozen abyss of the ocean floor and the sun-baked surface would cause the bridge to buckle and snap its clutch power, the friction that keeps bricks together. The Gulf Stream. Ocean currents would act like a giant hand pushing against the side of your bridge. Without industrial-grade adhesive, the Krogel, the lateral force would simply pop the bricks apart, turning your $5 trillion investment into the world's largest navigational hazard for ships.